Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8 and we will present about Mohr. Our group member contains me, myself, Tengku, Muhamad, Farid, Danial bin Ismail, my friend Aiman Hakim bin Azabullah, Mohamad Danish Irfan bin Muhamad Zaki, and Mohamad Iqmal bin Suzaimi. Before we go deeper into Mohr circle, I will explain a little bit about stress and strain. So we will go with the stress first. Stress are expressed as the ratio of the applied force divided by the resisting area. So the mathematically and units are below, which is force divided by area. So terminologies related to stress. We have three terminologies. The first one is stressor. A stressor is anything that has the effect of causing stress. The second one is stress capacity. While it is unclear precisely how much stress a person can carry, since each person has some stress in their life, we say he or she has a capacity for stress. Similarly, in case of rocks, how much capacity they must bear in stress. The third terminology is stress load. Everyone, even children, must carry some amount of stress in their daily life. When we think of stress as having an amount or quantity, we refer to this as the person's stress load. Next, types of stress. We have two types of stress, which is normal stress and combined stress. We will go one by one. We will go with normal stress first. Normal stress is the resisting area is perpendicular to the applied force. One of the normal stress, tensile stress. Tensile stress are induced in a body when it is subjected to two equal and opposite pulls, tensile force, as a result of which there is tendency in increase in length. It acts normal to the area and pulls on the area. Another example of normal stress is compressive stress. Stress induced in a body when subjected to two equal and opposite push, as a result of which there is a tendency of decrease in length of body. It acts normal to the area and it push on the area. Next, I will talk about combined stress. A combined stress is a condition of stress that cannot be represented by a single resultant stress. One of the combined stress is shear stress. Shear stress is a force parallel to the area resisting the force called shearing stress. It differs to tensile and compressive stresses, which are caused by force perpendicular to the area on which they act. Shearing stress is also known as tangential stress. Shearing stress is also known as tangential stress. Next. Another example of combined stress is torsional stress. The stresses and deformations induced in a circular shaft by a twisting moment. Next, I will talk about strain. Strain is when a body is subjected to some external force, there is some change in the dimension of the body. The ratio of change in dimension of body to its original dimension is called as strain. Strain is a dimensionless quantity. We will go to terminologies related to strain. First, longitudinal or linear strain. The description is strain that change the length of a line without changing its direction, can be either compressional or tensional. Second one is compression, longitudinal strain that shortens an object. The third one is tension, longitudinal strain that lengthens an object. The fourth one is shear. It is a strain that changes the angle of an object. Shear causes line to rotate. The fifth one is infinitesimal strain. It is a strain that is tiny, a few percent or less, and it allows several useful mathematical simplification and approximation. And the sixth one is finite strain. It is the strain is larger than a few percent, and it requires a more complicated mathematical treatment than infinitesimal strain. The seventh one is homogeneous strain. It is a uniform strain. It is a straight line in the original object remains straight. The parallel lines remain parallel. Circles deform to ellipse. Note that this definition rules out folding since an originally straight layer has to remain straight. The next one is inhomogeneous strain. How real geology behave. And deformation varies from place to place. Next, I will talk about the types of strain. The first one is tensile strain. Tensile strain is when ratio of increase in length to the original length of the body when it is subjected to a pull force. Tensile strain equal to increase in length divided by original length. Next is compressive strain. Ratio of decrease in length to the original length of body when it is subjected to push force. Next is volumetric strain. The description is a ratio of change of volume to the original volume. Next is shear strain. The description is strain due to shear stresses. Tensile strains are considered positive in case of producing increase in length. Compressive strains are considered negative in case of producing, and it is a decrease in length. Lastly, I will talk about relation between stress and strain. So, stress and strain are related with some law, which is Hooke's law. The description is within elastic limit, the ratio of stress applied to strain developed is constant. The constant is known as modulus of elasticity or Young modulus or elastic modulus, and it is related with mathematically. I think that's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Iqmal bin Suzaimi. I'm from 5BME1. Would like to present about the how stress and strains effect when under different angle. Alright, sign convention for strain. As we know, tensile strain are positive when compressive strains are negative. The strain defined earlier was known as linear strain or normal strain or the longitudinal strain. So let us define the shear strain. An element which is subjected to a shear stress experiences a deformation as shown in the figure below. The tangent of the angle through which two adjacent sides rotate relative to their initial position is termed shear strain. As we know that the shear stress actually acts along the surface. The action of the stress is to produce or being about the deformation in the body. Consider the distortion produced by shear stress on an element or rectangular block. So let we see at the second slide. Alright, let us take a look at this slide. So this shear strain or slide is theta can be defined as the change in right angle, or the angle of deformation y is then termed as the shear strain. Shear strain is measured in radians and hence is non-dimensional. It has no unit, so we have two types of strain, for example normal stress and shear stress. So this is the Hooke's law. A material is said to be elastic if it returns to its original unloaded dimension when load is removed. Hooke's law therefore states that stress divided by strain equal to constant. There we can see they have unit for the stress and the strain. Next we can see the modulus of elasticity. Within the elastic limits of materials, for example, within the limits in which Hooke's law applies, it has been shown that stress divided by strain equal to constant. This constant is given by the symbol E and is termed as the modulus of elasticity or Young modulus of elasticity. Alright, for this slide we can see the three-dimensional state of strain. It is considered an element subjected to three mutually perpendicular tensile stress, for example sigma x, sigma y, and sigma z as shown in the figure below. If sigma y and sigma z were not present the strain in the x direction from the basic definition of Young modulus of elasticity, it would be equal to strain x equal to sigma x divided by Young modulus. So the effect of sigma y and sigma z in x direction are given by the definition of Poisson ratio to be equal as Poisson ratio sigma y divided by Young modulus and negative Poisson ratio sigma z divided by Young modulus. So this negative sign indicating that if sigma y and sigma z are positive, for example tensile, they tend to reduce the strain in x direction. Thus the total linear strain in x direction is given. Alright, for the lastly we can see the two-dimensional strain. For example, the system, the stress in the third direction becomes zero. For example, sigma z equal to 0 or sigma 3 equal to 0. Although we will have a strain in this direction owing to stress sigma 1 and sigma 2. Let's take a look at the picture below. So at the right picture we can see that a strain can exist without a stress in that direction. So solution of above two equation yields, for example, we can see sigma 1 equals to Young modulus divided by 1 minus Poisson ratio squared, and the sigma 2 we can see Young modulus divided by 1 minus Poisson ratio squared. So last but not least we can see that shear stress actually along the surface. The action of the stress is to produce or bring about the deformation in the body. Consider the distortion produced to be shear stress on element or rectangular block. That's all from me. Thank you and Assalamualaikum.
Hi, Assalamualaikum. My name is Aiman Hakim and I'm from 5XBME3, and today we from group 8 will do a video presentation about Mohr circle. We start with the introduction first. The circle with that equation is called a Mohr circle. It was named after the German civil engineer Otto Mohr. He also developed the graphical technique for drawing the circle in 1882. The transformation equation for the plane stress can be represented in graphical form by a plot. It was known as Mohr circle. So this graphical representation is extremely useful because it enables you to visualize the relationship between the normal and shear stress that acting on various inclined planes at a point in a stress body. By using the Mohr circle, you can also calculate the principal stress, maximum shear stress, and stresses on inclined planes. So we're moving on to the stress transformation equations. This stress transformation equation was derived by equilibrium of a plane stress element, and what they do is they describe how to go from a given state of stress into a new state of stress at a different orientation, as you can see on the slide, the right one. So we move on to the established coordinate system. So this is our local coordinated system for the given plane stress element, and normally the horizontal one is plus x-axis and the vertical one is plus y-axis. And now that we have established coordinated system, we are ready to define the stresses. And here it's really important to make sure that we distinguish between the positive and negative stress based on our coordinated system. The red arrow, the horizontal one, the red arrow, the normal stress here is positive sigma x because it's causing tension on the face at the right one. Meanwhile, the red vertical arrow will be plus sigma y because it causing tension at the face on the top. And the red arrow on the top right here is plus shear stress, because the reason why it's positive is because the red arrow is in positive x faces and in the y plus y direction. These points represent the normal and shearing stress acting on the x and y faces of an on an element for which the stresses are known. In plotting this point, we must assume that the tension as plus, the compression as minus, and the shearing stress as plus when its moment about the center of the element clockwise.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Danish Irfan, and I will continue the slide with derivation of Mohr circle. If we vary theta from 0 degree to 363 degree, we will get all possible value of sigma x1 and tau x1 y1 for a given stress state. Eliminate theta by squaring both sides of first and second equation and adding them together into one equation. So as you can see in the slide, on the top left we have open bracket sigma x1 minus sigma x plus sigma 2 over 2 close bracket squared plus tau x1 y1 squared will be equal to open bracket sigma x minus sigma y over 2 close bracket squared plus tau xy squared. And then we can define the sigma average and radius. Sigma average will be equal to sigma x plus sigma y over 2 and radius will be square root of open bracket sigma x minus sigma y divided by 2 close bracket to the power of 2 plus tau xy squared. Next, we can substitute for sigma average and radius to get the final equation, which is open bracket sigma x1 minus sigma average close bracket to the power of 2 plus tau x1 y1 squared will be equal to radius squared. The circle with the equation is called a Mohr circle, named after the German civil engineer Otto Mohr. He also developed the graphical technique for drawing in the circle in 1882. The graphical method is a simple and clear approach to an otherwise complicated analysis. Next, we will move to the second slide, which is sign convention for Mohr circle. Based on the diagram, shear stress is plotted as positive downward, and theta on the stress element will be 2 theta in Mohr circle. This is a must in all Mohr circle usage. Next, I will continue the slide with procedure of constructing the Mohr circle. First, draw a set of coordinate axes with sigma x1 as positive to the right and tx1 y1 as positive downward. Next, we have to locate point A, which represent the stress condition on the x-face of the element by plotting its coordinate, which is sigma x1 equal to sigma x and tx1 y1 is equal to txy. Note that the point A on the circle corresponds theta equal to 0. Next, we have to locate point B, which represents the stress condition on the y-face of the element by plotting its coordinate sigma x1 equal to sigma y and tx1 y1 equal to negative txy. Note that point B on the circle corresponds to theta equal to 90 degree. Next, we have to draw a line from point A to point B, a diameter of the circle passing through C. Point A are B at the opposite end of the diameter and therefore 180 degree apart on the circle. Next, we can, by using the point C as the center, we can draw the Mohr circle through point A and B. The circle has a radius R. The center of the circle C at the point having coordinate sigma x1 equal to sigma average and t x1 y1 equal to 0.